Okay, welcome to our Bucky call for the weekend. And I'm getting an echo in my voice. I'm going to have to resolve that over here somehow. And maybe Lee can mute her phone. Lee, can you mute your phone?
Uh-huh.
That should eliminate the echo. Have you muted your phone?
For some reason, the sound has become very bad since you started the recording. Is there
Okay.
something changed with your microphone?
I just muted Lee's phone, and
No,
that
that's bad.
stopped the echo.
That's good.
So is that better? Okay,
Yeah.
very good. All right, good. So welcome to our Bucky call for the weekend of August 30th and 31st, I suppose, depending on which continent you're on. And we have an old friend coming back into the fold, Fred DuPont. And maybe what we can do is, I don't know when the best time for you to maybe give an introduction, Fred. Would that be right at the beginning, or let's let everybody go through and just say how they're feeling, set themselves up, and then why don't you introduce yourself on your welcome in? So we'll go ahead and the last guy to share will be Fred. So here we go. Joe, how are you feeling, and what do you anticipate for today?
I'm feeling pretty good. Got a lot going on, a lot of stressful things, I've shared with everybody here at some point. And, I'm just grateful for everybody's friendship. And so I had a pretty good day. And I'm keeping up with the most important tasks. I'll just say that. But I'm happy to be here. I'm not here just as a distraction to learn. I'm also here as to be reminded of how good our group is. So with that, just looking to continue through Amy's book. I thought kind of getting through division by multiplication, I think is divide to multiply is been especially beneficial for me. And things are becoming a little bit more clear in a lot of different ways. So with that, it's great to see everybody. Lee, how are you feeling? What would you like to take away from today?
You need to unmute your phone. Here we go. Go ahead.
My phone doesn't like me. It's an old phone. But I am enjoying my life very much. And I was very interested in what was said last week. I was blessed to be able to read a little bit of what was said so that I have more understanding. Since I don't have the math backing as all of you, but I am very grateful for being able to join you today. And Manu, how are you? And what would you like to give us as a...
Thank you, Lee. I am emerging. I'm just waking up now. So I feel good. The weather is a lot better in Cape Town than before. It's sunny and very temperate. Welcome to Fred, an old friend from a very long time. And what I look forward, what I've been having here is that we have all to realize that the universe is all energy field. And energy is flowing and there's continuity. And that we've got to position ourselves in order to leverage on that continuity to influence far with systems that we build. So I look forward that we continue on this. This is a very interesting book that is really kind of calling us on that understanding. So I wouldn't like to waste more time. Richard, how do you feel? What do you expect?
Well, I'm feeling pretty good today. For some of you know that our daughter, who has been on a book reading tour of her first novel, and at the end of a week-long session last Saturday, she woke up early Sunday morning with a serious pain that turned into an emergency gallbladder infection, a fairly serious surgery on Friday, and today she's been discharged and is likely going to be able to take a flight home. But she's been on her own for this last 2 weeks.
Where was she?
Pardon?
Where was she?
Oh, well, she was traveling across northern BC from Prince George to the coast at Prince Rupert. And her husband lives in southern BC near the US border, and we live in Alberta about 2 days away from where she is, car travel. So it's been a tense several days for all of us. And so
Sure.
good news today. So that's been good. And
Is she
and I
the one
just
who has been in the, I'm sorry to interrupt you, but is she
Yeah.
the one who got in the accident? Or the biking accident?
yes, you're right. She did. Yeah.
Okay.
But she's back on a new bike and still doing a lot of biking. Yeah, that's thoughts. And I was just reflecting on what Manu was saying about energy and flow, and it made me think of something that Fuller was always about, and I think it's covered in Fuller explanation. But his concern that the flow gets stopped by the different elements in universe, whether it's sovereign nations or ourselves as individuals. And I always remember him talking about sovereign nations, or every nation being allowed its own self-determination, is like a series of blood clots. He called them, I think, 190 blood clots in the blood system of our Earthian system. And I think that's important for us to pay attention to in terms of the emphasis that Manu was sharing. So where are we? Fred, how are you feeling? And what's your interest in today's reading?
Thank you, Richard. I'm feeling very excited to be, I would say, back, but for most of you to be there first time. So I got a Shoshin mindset, I got a beginner's mindset in order to try to get up to pace and try to see how I can wedge in and fit in and earn my spot in this brilliant group. A little bit of my background. I'm French. I've been living in China for 30 years.
Wow.
My wife died last year. Some of you knew her, Lucy. Lucy, yeah, she died of cancer. She had a long fight and she lost. It was difficult from the start because the diagnosis was very late. She had a stage 4 colorectal cancer with metastasis in the liver, soon metastasis in the lungs. And after 5 years, a bit short than 5 years, and she just passed away last year. So whenever somebody says, like Richard just did, that somebody is alone in hospital, I just get difficulties. I get emotional about that. I've held her hand all the way from every time in hospital, and anyway, she's departing now. I used to be industrialist. I used to have factories here in China manufacturing furniture and small light industry products. And I was on the Bucky call through Kelly, which I met in 2004. That's more than 20 years ago in Australia at the Rich Dad event, Kiyosaki event. And then he invited me to the call. I think I joined the call in 2006. And I was with the call, the Bucky call, the original Bucky call, until 2017 or 18, something like that, with some short pauses in the middle. And I am here because I've missed it. So I've missed it. So I'm here out of both nostalgia and the desire to exercise my mind, to get some deep thoughts, deep conversations with people, with like-minded people that want to learn something and learn from each other. So that's it for me for today. And so thank you all. Steve, what are you how are you feeling today, and what is your desired takeaway?
Good. Thank you very much, Fred, and it's good to have you back. I have real fond memories of your participation, and suddenly I'm conducting these calls, and so excuse me for my beginner actions. And I'll do the best I can, and I'm open to suggestions along the way. Richard, did your daughter have to cut her book tour short?
Just by one visit. She was on a week-long trip, stopping at several different places where the lead character in her novel actually traveled to, and she would stop at an environmental sort of area and read a chapter or read a section from her
Wow.
book that had to do with her lead character and where she was on her journey. And so she finished in Prince Rupert on the coast of British Columbia, and she had one more on the way south that was at a friend's place in a major indigenous sort of community in northern BC. So she had to cancel that one, but otherwise she actually achieved what she was had set out to do.
Wonderful.
And her experience, unfortunately, is probably genetic, because when I was about her age, after I finished a 5-day training of trainer course, I woke up in the middle of the night with exactly the same problem, ended up with an emergency gallbladder surgery, a gangrenous gallbladder that was almost not got. And so I feel sorry that that kind of genetics passes on through to another member of the family. But yeah.
Joe has posted a comment in the chat asking if you have a link to her book, to your daughter's book.
I probably do at some point. Yes, I can.
If you
I can share it.
Share it either now or sometime. We're all anxious to see it. As a book writer over here and having a book 1/3 of the way done, I aspire to having a book tour. That would be a wonderful thing. So that's great.
Yeah.
Okay, good. And Fred, thank you for sharing. Thank everybody for being here. And we left off with a reading in Amy Edmondson's book, Fuller Understanding, on page 183, and we're about to jump into the icosahedron. We're towards the end of the Jitterbug session, and we actually may have read this paragraph, but I think we'll go ahead and begin there as we go.
How are you doing, Steve? Really quickly.
Oh, how am I doing? I got to play some music this week. That was exciting. A band hired me to play guitar and sing, to sit in for a guy who couldn't make it. And that was quite rejuvenating.
Cool.
And then I went to see Toto and Christopher Cross in concert. And then last night I went to another friend of mine, one of the guy, in fact, who hired me to take his place. I went to his band thing. So I'm kind of tired. I'm kind of strung out from all of my projects, everything I'm trying to do, and then still have fun at the same time and be a human being. So I'm a little strung out. Thanks for asking. I probably didn't state how I felt when I first on the call. So thank you for asking. Yeah, Fred.
I'd like to ask, what book are you writing? What is it about?
I'm writing a book called Extreme Mindfulness. It's a concept that I've been working on, and I think the subtitle is going to be something like How to Experience Enlightenment for 10 Minutes in 30-second intervals. So that's one of my working titles, and that's one of the themes of my book. I don't know if you know Vipassana, Vipassana meditation. It's a 10-day meditation with 9-day vow of silence.
I heard you talk about it.
Yeah.
The call I listened to from 2023 was the one you started by explaining what you've been doing, and I'm glad you did not lose your legs. And Pasana, doing a 10 days silent retreat with Pasana is on my bucket list.
Mm.
What did you say about the 10-day retreat? What?
Doing 10 days
Yes, the
silent retreat with
Goenka. Have you done one of those?
Is on my bucket list.
Oh, it's on your bucket list. I'm signing up for a 14-day in October.
Where about?
It's in Lava Hot Springs, which is about 2.5 hours north of Salt Lake City.
Okay.
And that's where I'm going to go. Most of my experiences have been at the North Fork Retreat in California, just at the south entrance of Yosemite. There's a beautiful monastery, beautiful grounds. If you're coming over from China, that's the best place to go. But I think there are places in China that, or maybe not China, but certainly you can go. There's Thailand and India. There are a lot of places around. There may even be a retreat center in Australia. I don't know.
Yes, there's plenty of Japan, Taiwan, Hong Kong, Vietnam, Thailand. I checked that out. Yes.
Very cool. Well, it's a profound experience, and I'm going to write a book and try to explain to people how to I've done like 25 of those 10-day workshops, and so I've gotten a pretty good idea of what the essence of that is. And having been certified as a clinical hypnotherapist, completed all that education, I understand hypnosis and self-hypnosis and understand how to create intentional focused awareness. And that's what my book is about, how to create an intended focus awareness and the difference between that and a trance or self-hypnosis or things like that. So thank you for asking, but that's what it's about.
Well, thank you very much for this very thorough answer.
Very good. Good. So without any other, if everybody's good, we'll move into our reading on page 183.
I'll just say this. I was reading about intention a little bit earlier, but I'm not going to derail it. So we can get to the reading. It was just something that you would appreciate, and I'll text you. I was actually going to text you literally.
Well, go ahead and share. Go ahead. We're all friends here.
No, it was just really quickly, different ideas about how intention emerges and how Roger Penrose feels like it emerges, through microtubules, in the brain, and then that process is something that computers can't necessarily replicate.
Right.
So anyway, I mean, we could talk about it, but yeah, I think that there's a lot of it's interesting because you hear about these different theories, especially about when it comes to language and how language actually allows us to form intention, all those things.
Yeah,
that's real, but to a certain extent, can systems, and he relies on Gödel's theorem for that. The incompleteness theorem, as far as a way of actually saying that, that it's not just necessarily language, that it's something deeper in the brain.
Yeah. I think Gödel's incompleteness theorem really, discusses or at least obviates that the math is a great metaphor. It's a great way to look at the universe,
Correct.
And it doesn't solve all the problems.
That's correct.
And I think that same issue is now occurring with AI.
I agree.
The AI, these language models have got everything hooked together, but they're not going to intuit anything, probably. They're going to
Right.
synthesize some combinations, but in terms of taking that next leap, and I think it puts a burden on each of us to be the individuals that we are and use our own intuition and our own knowing. And I think sessions like this are really important.
They're
Yeah.
the connections that make us human.
Yeah. Okay. Any other comments on that? All righty, we'll move into the book. And usually what we do here is we share some reading. Sometimes one person
By
ends
the
up
way,
reading
I'm
the whole thing.
sharing.
What's that?
I attended for the first time a fully 2-day immerse AI experience
Oh, where?
on Thursday and Friday in Cape Town.
In Cape Town?
For what is worth, yes.
In
It was
person?
very interesting. Yes.
What
All
was
right.
2 days?
A fully immersion.
AI is called AI
Oh,
Power Experience. Here it is. That is the book, my notebook.
ah,
Can you share those? Or
It's called the AI Power Experience.
was it
It's
a
run
just
by
a,
an organization called Future AI.
uh-huh. Did they focus on one of the engines like chat
We did all of
GPT-5?
that. Everything.
You did Grok, you did a whole bunch of different ones.
Yes.
Cool.
Yeah. I mean, and exactly the what I got at the end
Mm-hmm.
is that it's never going to intuit. We are sentient.
Yeah.
AI is going to be very good at combining the division, but they are never going to be analogs.
Yeah.
And you need the digital and analog as a dual
Mm.
to be able to describe the whole process. They're never going to be like that.
Yeah.
Yeah.
I'm convinced my
They're
book.
going to be good at crunching big data, finding patterns.
Yes.
right.
Sometimes patterns that don't mean anything to the problem that you're actually trying to solve.
Yeah.
And that's where your role, the role of human,
Yeah.
as local problem solvers
Yeah.
in the service of the integrity of universe
Mm-hmm.
is. Yes. So we have to redefine what we do in relation to the technological advances that we have. Okay.
Wonderful. And I hope my book is like a handbook for someone to find their intuition, to find their inner knowing, to find that thing that makes them unique
I
and
think
manifest it, be willing to manifest it.
I
So
think it will, Steve. I mean, the derails, but yeah.
I hope.
absolutely.
Well, you guys are really good feedback for me. So before it goes out there, I'm sure you'll get a chance to rip me apart and make me better. All right. Okay, with that, if everybody's ready, we'll go back to the topic at hand. I'll read a couple paragraphs here to start. At the bottom of the page, icosahedron. The Icosa, and this is completing the Jitterbug process. If this is the Jitterbug chapter 11, so here we go. The Icosahedron, however, refuses to cooperate. Its volume of approximately 18.51 is not as appealing as the whole number ratios shared by the other stopping points. Jitterbug now introduces a rationale. The icosahedron is a phase that falls in between octahedron and vector equilibrium, rather than a definitive stopping point in the flow. The jitterbug is a continuous transformation through countless transitional stages, both regular and not, and at certain intervals, an ordered polyhedron emerges. Found when the jitterbug is simply open as far as possible, the cube octahedron is definitive, absolute zero. The octahedron clicks into place when 6 pairs of vertices suddenly come together. No ambiguity at either point. The icosahedral stage, on the other hand, is always approximate. We have to eye the distances between the vertices, guessing whether or not they are equal to 1. The dance does not stop naturally at this point. We just recognize that the familiar shape along the way from vector equilibrium to octahedron. It is thus a transient phase of the jitterbug, with no reason to stop and rest, no choice but to continue. Anybody want to comment on that? It's interesting to me that Amy would say that the icosahedron has no choice.
Yeah,
That's kind of interesting.
that is very interesting, actually.
I'm suspecting something.
Yeah.
Look at the icosahedron.
Okay.
Remember the phi. And remember the sphere. We are in the sphere. We intuit that our surrounding is spherical, because we are the center there, and then we imagine that around us, and that's the most logical, you have equidistance of all points. Therefore, our universe, which is what we consciously apprehend, is spherical. Now, we know that universe is made of a boundary in the form of a phi, and something that is structurally stable. And I suspect that the icosahedron is the most expanded stable state. Because if you take the total, we know that total universe equals structural universe plus phi. Do you agree with me in that identity? Total universe, that is the sphere, equal the structural universe plus the phi plus what moves the surfaces of these triangles that form the icosahedron. And there are 20 of those. What moves it into making it spherical? Note that all of these points, all of the vertices here, are points belong to the surface of a sphere of universe. All of this, the 20. So if you took this and you put in a ball, and then you inflated the ball in such a way that the ball is tangent to these vertices, you have inside this icosahedron the structural universe, because we can build it. It is vectorial. And you have inside of this, in order to have the smoothest, you have the golden ratio, you have the phi. So the cube octahedron, which is the maximum, the vector equilibrium of this, is of volume 20. But the icosahedron that is stable is of volume 18.5. It's not finite. It's 18.5 thing. It is because it is the convergence of rational numbers minus this icosahedron to find that volume over phi. I'm just saying that, I'm not saying that it's true. I'm just saying that it seemed logical to me that the dynamic equilibrium of universe can hold in that description.
Cool.
Does anybody have
Not-
any on what is, what she means by that there is no choice? That one
That was
quote.
my question. Why Amy would say that there's no that with the jitterbug, with all this energy and motion, that there's no choice. It has no choice. Maybe she's just using a colloquial term, meaning that the energy continues to flow and it has no choice.
No, it has choice.
No.
There's no choice in this. Look at this.
Let me say
This is
something.
this is the cube. Okay, sorry. Do you
Oh,
want to say
just-
something before I continue, Richard?
Yeah, I'd just like to add to the whole question of the energy and the flow. And in order to do that, there has to be some struts edges removed from the icosahedron, and then you get flow. So you end up with structure and flow working together, and so, I appreciate the reference to the spherical structure and what that means, but we also, I think, need to have the understanding of how the flow sort of comes out of it by removing the struts that then allows the compression down from the top triangle to the bottom triangle, and the torquing and moving through the octahedron down to the two-dimensional tetrahedron, and then the three-dimensional tetrahedron, and eventually down to an actual triangle, and then it can pop all the way back up. So it really has a lot of the elements of self-organization in that whole process as well. Yeah.
Well, let's continue to read, and maybe
May I continue here?
Sure.
Okay. Do you see this? This is our universe in its infinite form. If it unfolded until it's flat, this is the way it will look.
Our Earth, right?
For example, yes, I'm taking Earth as a model for our universe.
Mm.
Right. It will look like this. Okay?
Yeah.
Now, it's just folding, 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 and all of a sudden, this one went wrong. All of a sudden, yeah.
Yeah.
This is stable. To destroy this thing, I will need to outwardly, through my poles, exercise a force. Look at that. But it needs that. Otherwise, it is stable. It's a form of stability. We have this, huh? Steve, was it Joe who made us buy this? Or was it Susan?
I was wondering, it was probably Susan. I haven't seen that one.
Come on.
I haven't seen that guy.
No, you guys, you were to buy this and send me.
No, man.
Steve, I told you I didn't have it, and then you were to buy it and send me.
I got the ones that went. I got the ones that goes from the icosahedron to the cube. Let me go find that. I don't have the one that goes flat. And by the way,
so but that's what I was saying. That was my intuition. You have this, it's like that.
Yeah.
This is everything that we have, everything that we structured. The structure world that we know is contained into universe that is the sum of the structure plus the phi plus the rational, the one that is rational, because our universe is rational.
Right. And you just compressed the universe into a 2D plane. Yes. And because everything is a fractal, that is not only the Earth and the universe, it's me. And it's scary when you do that, Manu.
Okay, so that was my intuition. I think that's why she said it has no choice. Because when you fold it and it's in a continuum, it will forcibly take this form before you go anywhere.
Yeah. This is the one I have. This is the Earth. And somehow if I put pressure in the right place, there's the South Pole. Yeah. I think if I grab the South Pole, then it comes out and there's a cube inside of it.
Yeah.
So
by the way, this is from the Becky Institute, huh? This is from the Becky Fuller. It's from the Becky Fuller Institute. Yeah.
Right.
You can see that. It's from them directly. Yes.
Yeah. So evidently the cube is inside the icosahedron, so it must be a dual.
Mm-hmm.
Is the cube a dual of an icosahedron?
Because the dual of the octahedron is the cube octahedron is a vector equilibrium.
Is there, but this was inside of it.
Yeah. The cube will always be inside of it, though it's not stable.
But
It
it's
is
not
inside.
stable. Yeah.
Yes. It is one form that you're going to encounter. But the cube octahedron is the most expanded form of universe. And the octahedron, the two, yes.
That was the cube. Well, I haven't played with these for a long time. I feel like an imbecile. Anyway, it's been a long time since I played with these. I'm gonna leave this on my desk and see if I can get back to it. Anyway, go ahead, Manu.
Yes. So the what is it? Icosahedron is the maximum stable extended form of universe.
Cool. Cool.
And the vector equilibrium is the other one, is the maximum unstable.
Yeah.
Because you collapse a little bit the vector equilibrium to get into icosahedron.
Yeah.
Yeah.
And the thing that impressed me, Manu, is that you pointed out you have to squish it from the top, that there is energy from outside of this system that's influencing this system. That somehow has really impressed me. Okay, I'm going to
And
go
that
back
is actually the definition of the boundary by Fuller. Fuller never said that universe is just on its own. He said the sum total of our consciously and what did he say? You use another thing, apprehended.
Okay.
I have that definition somewhere. Yes. Okay.
Yeah, let's continue reading this. Maybe unless somebody else has a comment. Fred, did you want to throw in?
Are we? Can I share my screen? How do I do
Yes.
In this,
Definitely.
the ground rules here is anytime you want to share, you push your share button. There's no, it's very democratic. It's the most democratic Zoom I could come up with. If you want to share, you share.
The problem is not democracy. The problem is where's the share button? Oh, there it is.
There should be a green folder on your screen there. There you go. Ooh, universe is not a system.
Hmm.
The reason universe is not a system is that you cannot get out of universe.
Uh-huh.
Yes.
You can get in and out of systems, not in and out of universe.
Huge. That's really, really big. Thank you for sharing.
Yeah,
Okay, that's what I wanted to share.
that's very good.
Act unconscious.
How do I unshare that now?
I can, you should be able to push a stop button, but anybody can push a stop button. And as I begin sharing, then yours will go away.
Stop button?
No problem. Please share anytime you're inspired, Fred. Okay, so continuing to read.
Okay. I don't want to interrupt somebody speaking with
Yeah, but I like what you're doing. So here it says here, it is thus a transient phase of the jitterbug with no reason to stop, interesting word, and rest, and no choice but to continue, interesting. Similarly, the icosahedral vertices fall in between nodes of the IVM. The omnisymmetrical framework that outlines most of the symmetrical geometric shapes. One result of being out of phase with this matrix, which is also defined by close packed spheres, is that the icosahedron's frequency cannot be increased by surrounding it with additional layers of spheres or vectors. It cannot grow modularly. The initial choice of size or frequency is final. To change the frequency, a new model must be built from scratch. The icosahedron is thus restricted to single-layer construction. And here's the quote, the icosahedron must collapse to exist, explains Bucky. It always behaves independently of other polyhedra.
Okay. ask about Fred's? Oh God, I'm sorry. I'll come back to it, please. I'm sorry.
Oh, no, go ahead. What do you?
Fred's quote: "The idea that we're not in the system."
No, that we are in the system in
we are in
universe.
the system. But it's we are in the system, but let me see the exact quote again.
We were in universe. I'll share it. Here it goes. You cannot get out of universe. Universe is not a system. Universe is not a shape. Universe is a scenario.
Mhm.
You are always in universe. You can only get out of a system.
Right. So, and I have to think about this a little bit more, but I appreciate that. And is that what he talks about, the idea of happenings?
Yeah, a scenario is a happening.
Okay.
I think. Don't you all agree? A scenario is a happening. It's a star. He would use the word star, right? An event.
I would
Right.
say a scenario is the polarization.
Okay.
That's the way I would define it. It is, I imagine that it is like this. So those are, the scenario is the two poles. When you reduce anything to the 0 point, is the two poles. That is a scenario.
Okay.
It,
Yeah, that
it
makes
could
sense.
it could be something else, but that is to me that is a scenario.
Thank you. That's the way I was kind of understanding it as well.
Yeah. So what he's saying that is that the scenario is an externality. It's an
Right.
externality to our system.
Right.
This is a different quote you're sharing, Fred. That's interesting.
Yeah, I know this one. Yeah, this is the one CJ used to write about all the time.
Yes.
But yeah, non-overlapping events, all the physical components of which are ever transforming. This is exactly what we're talking about right now.
Yeah, because universe means what we are singing together at this time.
Right.
Verse, a verse. If you take say the Bible or the Quran, you have a verse, a surat. To say a verse means this. It is what we believe in. Let's just put it.
No, I mean it's exactly what we're talking about, and this is the idea of like that explains what Amy is saying with the idea of no choice. Is that there's the constant there's an infinite amount of happenings, infinite amount of scenarios, right?
But the difference is that we have agreed, we insiders have agreed that is our rule.
Right.
That's why it is dynamic. At the boundary of it, we are always validating and invalidating points. That's why we are transgressing and regressing all the time.
And that's why everything's unfolding.
Yes.
Yeah, that makes perfect sense. I appreciate you sharing that, Fred.
Yeah.
I found
maybe it's not a system. Maybe it's not a system, Fred. You are a mathematician, but it's a set, isn't it? At least.
How many more of
not
those?
a mathematical definition.
Yeah, I'm just saying. It's not a system, but it's a set.
It's I mean, Bucky has. If we, I guess we are. If we trying to understand what Bucky meant by universe, he's got many different approaches in order to try to understand and make us understand what his idea of universe is. There's in the cards of his dictionary, there's like 120 different cards about universe. I don't know if you can see it, but I put on the screen the one you were trying to remember.
Yeah.
Universe is the aggregate of all of humanity's consciously apprehended and communicated experiences, which aggregate of only partially overlapping events in some totally a lot of yesterdays plus an awareness of now. Now, to the question, is there an infinite number of scenarios? I have no idea, because Bucky says universe is finite.
Yeah.
So can there be an infinite number of finite and still call it finite? That I don't know. This is beyond my pay grade. Sorry about that.
I would say there's an infinite possibility of finite happenings.
I don't know. I'm very wary of the soundbite here.
Yeah, I hear you.
Cool. Topologically, what I don't know is infinitely bigger than what I know.
Correct.
So universe here is
maybe
part of what I do. Can you put it up again, Steve?
Yeah.
That universe definition. So what I know is universe, because it says consciously apprehended and communicated experiences, which aggregates. Yes. Where is it?
Down here.
Which aggregate, yes. Which aggregate, yes. Only partially overlapping events in some totally a lot of yesterdays plus awareness of now. Exact.
That's everything right there.
Yeah.
That's the whole equation right there.
I took Fred's 3 definitions and stuck them on one sheet here.
Yeah, keep that in the chat. I mean, because that's actually, I know that that's out there already, but I appreciate that. No, because that talks about the idea that the limits of what we can actually infer about the world.
In my book, I'm going to talk about the space between the nows. That reality is the isotropic vector matrix. It's what is between the nows. That's going to be one of my thoughts.
Yeah, well, that's important when you relate it to the idea of truth as well.
Yeah.
Because what happened at the border? What happened at the boundary?
Right. Right. Well, what happens at the boundary is the between the nows, right?
Yes, that's another way of trying to say what Steve was saying by in between.
Yeah, and this is the idea of truth being a tensor, not a scalar.
It's important to note that universe is not the whole.
Right.
Really?
Universe is not the whole. Whole means WHOLE. Is not. Because there's what I don't know.
Oh, what you don't know is in universe.
Yes.
Premise,
so what I know plus what I don't know is a whole.
Yes, but Bucky's premise about universe is that everything is in universe.
Everything we know.
Everything we don't know also.
And everything we don't know. Both are in the universe. The universe is the known and the
everything.
Where is that, Steve?
And everything that's not happened.
It's in cosmology. I'll get the quote.
Okay,
out
yes.
right
now. Get the cosmic hierarchy, because that is an important problem.
Yeah.
An important clarification.
It is.
Cosmic. Hang on, I should be able to find it quickly here. Let me see. Here's another one from Fred. You guys ponder that while I find the cosmometry thing, or the cosmography quote. Go ahead and discuss that, Fred.
I'm listening. I need to attend to something.
I can
Because to me,
I can send you the cards, Steve. You don't have to take screenshots.
Well, I don't mind screenshots. And if you want to send me the card, I'm happy. Let me see, cosmography. Do you guys want to discuss what Fred put up there?
Well, it is just a lot of varied definitions. And I was
Yes.
pondering on the definition of the aggregate there. Because if it's the aggregate of all humanities consciously apprehended and communicated, it means universe is not the whole. The whole is more than universe.
Everything is in universe. That's the premise.
Everything we know, Steve, Fred.
It's not,
Not
me.
everything.
It's not me. It's Bucky. Everything in universe. If you
Okay,
remove
so take the first.
if you remove this premise, then you can't understand what he says anymore.
Okay, can I suggest that we put again up the first definition that you put, that universe is the aggregate of all humanity's consciously apprehended and communicated experiences, which aggregate only partially overlapping event in some totally a lot of yesterdays plus awareness of now. If you put that one, it seems to contradict what the other one is saying. I say again, it seems to.
Sorry, I'm trying to find the one where he says everything in universe.
Maybe we can continue and then we'll discuss this point later.
Yeah, I'm actually frustrated because I have his hierarchy, which includes known and unknown, and relates known and unknown to universe. And it bothers me that I'm not able to call that up in just 30 seconds flat.
That's okay. I mean,
That frustrates the toots out of me here, my computer.
I know you usually have that.
Yeah, so we'll just continue to read then. And
Is the universe and the cosmos the same?
According to the hierarchy, I think so, but I'm going to find it and we'll continue to read because there are some parts here that pertain to our discussion. I read the icosahedron must collapse to exist. Explains Bucky, it always behaves independently of other polyhedra. The icosahedron goes out of rational tunability due to its radius being too little to permit it having the same size nuclear sphere, therefore putting it in a different frequency system. Accordingly, its volume does not fit in the cosmic hierarchy of rational systems. I have this cosmic hierarchy someplace and I'm not able to find it, and that's frustrating to me. Anybody want to comment on that, or shall we continue to read?
I think we'll continue.
Cool.
Yeah.
Who wants to read from there?
Oh, I don't mind reading.
Okay.
Single layer versus IVM. What are the consequences of the icosahedron's independence of the cosmic hierarchy? As a collapsed vector equilibrium, it is always a shell, a single layer construction. The icosahedron, in order to contract, must be a single layer affair. You could not have two adjacent layers of vector equilibria and then have them collapse to become the icosahedron. So you can only have this contraction in a single layer of the vector equilibrium, and it has to be an outside layer, remote from other layers. It may have as high as a frequency as nature may require. The center is vacant. That's 456-20 to 456-21. Accordingly, as we recall from Chapter 8, the design chosen by nature for many protective shells involves icosahedral symmetry. From the microscopic virus capsid to larger visible with an ordinary microscope, radiolari, did I say that correctly? The cornea of an eye and a plethora of other elegant creations. Transuniverse versus locally operative. The vector equilibrium, railroad tracks.
Can I make a comment before we get into that?
Sure. Please do.
Remember that we, humans, will mimic what the universe does. When you have a fisherman with a boat and a net, when he goes fishing, he sees, for example, he has clues from birds. Let's say a seagull plunging to get fish. So he's going to go and throw his net, right? Throw his net and set the boundary. Set the boundary of what you want to do. That setting is outside of the process that is going to be to collapse to cage fish that are going to be his harvest. So if that is so, that boundary is the icosahedron, like the metaphor. The icosahedron does not derive from the structural flow. It is there as a boundary of a system. The boundary of a system is not the system, it's the polyhedra that envelopes it. Is the you say polyhedron? Polyhedron, yes. That envelopes it. So that is my little intuition about this. So icosahedron and shell, and then she talked about that here. The shell, if you take an egg, the shell is on its own. It's a set that closes on its own. And the yolk and the white of the egg are inside. That is living structure. That's a living whatever that you have that's going to create life. But the shell protects it. That's why I make I compare it to maybe the fire. Because to me the fire envelop my structure. Okay, I'm true with that.
So I'm trying to get maybe we'll come back to it. I was gonna ask about the mimic aspect of what you were talking about, but we can come back to that. I have to think it through.
Yeah, the net that I throw does not depend on the fish and the water that is in there. It is external. I throw it, I cast it.
Okay.
I cast, and that fixes, if there's any fish that is inside there, there's possibility that I'll catch the fish.
Okay.
I found this. This is the only thing I found from Synergetics Cosmic Integrity, and it bothers me because I've written a couple papers on this, or at least summarized a couple things from the book, and this is all I can find in the cosmic hierarchy. But this is at the bottom of the hierarchy is the 18 me's, but at the top of the hierarchy is cosmic integrity, then synergy, then nature, then unknown, and then
Yes,
universe.
and then universe.
So universe is what is known. And so cosmic integrity includes universe and unknown, and evidently universe is known. That
was my understanding. I mean, that's the way I've always understood. But
and I understood differently, that universe was known and unknown.
Universe is a container from what I've understood it to be.
Well, evidently it's scenario of overlapping human experience, non-local. or non-simultaneous overlapping human experience, as Fred pointed out.
Yeah. Yeah. Look, Joe there, look at 38. Look at the sign. That inverted V means that what is on the left is greater than what is to the right.
Right.
In the hierarchy there, on the top of that sharing.
Across here.
38, yes.
Yeah, this
So
was his.
That's cosmic integrity, yes.
Yeah,
The
this
sign
is
for
cosmic integrity. Yin yang. He also had this
Yes.
down as the me.
Yes.
Yeah.
So the pure principle is greater than any shape or any structure that you might ever have. Is a pure principle. Like to say duality is a pure principle. It applies everywhere, including the universe and out of universe.
Okay. We left off here. Joe, do you want to continue?
Yeah, sure. Transuniverse versus locally operative. The vector equilibrium railroad tracks are transuniverse, but the icosahedron is a locally operative system. That's powerful. We can go over that. That's micro and macro. Fuller's ambiguous and somewhat mystical declaration becomes almost straightforward after the Jitterbug demonstration. Vector equilibrium is incorporated into an infinitely extending network. Conceptual and timeless, vector equilibrium is everywhere. It is the balance of forces at the root of all phenomena. The icosahedron, on the other hand, is always a special case collapse, an aberration in the omnisymmetrical frame of reference. Aberrations are finite, local, inescapable, stuck in time, as we recall from angular topology. Wow, that's actually making angular momentum make a lot more sense. The icosahedron is thus fundamentally different from the vector equilibrium, which, with its timeless perfection, permeates all of universe. Fives. Fivefold symmetry dominates the icosahedron, distinguishing it once again from the cosmic hierarchy with threefold, fourfold, and sixfold rotational symmetries. This is another sign of the icosahedron non-conformism. It's full of fives to begin with, the obvious five triangles around each vector vertex, determining the symmetry about each of its long axes. Then its 30 edges fall into 5 sets of 6 orthogonal edges, that is, 3 parallel pairs of mutually perpendicular edges. Figure 11-3 highlights the 5 distinct sets of orthogonal edges. The edges can also be grouped into sets of 5 parallel edges embracing the equator in six different directions, joining the midpoints of the 6 edges of one set displayed in figure 11-3a. We discover an octahedron hiding inside, implicit in the icosahedral symmetry, in one of 5 possible orientations. Figure 11-3b. The icosahedron may be out of phase with the rest of the IVM family, but it displays many significant relationships to these other shapes, which begins unexpected, which being unexpected are all the more fascinating to uncover. A few examples will be given below, and there's only room for further exploration. Just sorry about the mess up on that previous line. As in our earlier development of the cosmic hierarchy, we investigate how various shapes fit inside each other and thereby learn about similarities in shape, volume, and valiancy. There's letter A and B, and that's figure -11-3. The octahedron within the icosahedron. We've covered that pretty extensively. A is 5 sets of 6 edges. Each set of 6 consists of 3 mutually perpendicular pairs. B, connecting midpoints of one set of 6 edges outlines a regular octahedron. Whereas the cosmic hierarchy relationships are consistently straightforward and balanced, just bisect edges and connect midpoints to generate the next shape. Whenever the icosahedron is introduced, more intricate connections emerge. We therefore have to look somewhat harder to find these new relationships, which highlight the icosahedron's transitional role in the hierarchy.
So these are those pictures that Joe has been reading about.
Yeah, we kind of covered that. I don't know. Well, maybe not that one. I don't
Yeah.
know. I mean, we covered them all in some way, shape, or form. No pun intended.
Yeah. I put something in the
chat.
In the chat, yes, about what the role of the icosahedron. Don't laugh at me, please.
Wait a minute, hang on. What is it you're talking about here? The icosahedron is akin to a catalytic ingredient of nature.
You remember when you read, when you said here, listen to what Joe said at the end.
Yeah.
He said that whenever you introduce the icosahedron, there seem to be more complex relationship that emerge, that result.
Yeah.
So the icosahedron does not flow in the logic of the collapse of the vector equilibrium to the other stable polyhedra. It seems like it is like a catalyst. If you take, let me just give you an example. If you take shale, you know the shale, right?
The what?
A shale, you take a shaly rock.
Okay.
Shale.
Shale.
Okay.
Shale.
Yes.
Yeah.
If you have shale has 2 ways of organizing. The general structure of a shale is layers, one layer on top of the other. That's why it is not permissive to the vertical migration of hydrocarbon. It's one layer on the other. Shales are very, very good seals. But there is a variety of shale that they call dispersed shale.
What's it called? I'm sorry.
Dispersed.
Dispersed. Okay, thank you.
Yes. So the mineral of shale got into the pores of a rock, and what it does, it imprisons water to make a barrier in such a way that there is no flow of hydrocarbon. You know, the hydrocarbon and water are not miscible. Only at high temperature that they become miscible.
Oh.
Right. So what happens now is that in the flow of hydrocarbon, in the pore, because hydrocarbon is contained in pores and flows through faults or fissurations, right? So, sorry, I take away my right. So the grain of shale that you have in there is going to agglutinate water and block the pore, just like, for example, black folks, they have these problems in that when they take salt get into their body and then block and then imprison
High
water.
blood
Yes, for high blood pressure, result in high blood pressure. That's why it's endemic with people of African descent.
Yeah.
So the icosahedron is like that. It is this ingredient that introduced in the system changes everything, like a catalyst does. And again, that link a lot in mathematics. Fresh will remember what you call the theorem of residues. Yes, the theorem of residues.
Out of the blue, I cannot cite it.
Yeah. You know about the theorem of residues, right?
I've got some residue of it.
Yes, the theorem of residues, they say this, they call it also the Gaussian theorem, is that if you have any domain that is regular, but at one point only is not regular. Think about a water container with a rock into it. What is inside that rock is not regular to what is in the water around it.
Okay, there's a theorem for that.
Yes,
I forgot
and
the
it
name.
says,
I forgot
yes,
the name of it. It's very funny theorem.
yes,
It says that on a cow, there will always be two hairs that face each other, no matter how well you comb it. And that's a topology theorem. That is, if you comb the hair on the surface on any finite and closed surface, you always get to a point where the hair face each other. You cannot have all the hair aligned.
Yeah.
That's the one you mentioned.
Yes, but the theorem of residue say that the utility, let's just say, the value or whatever that you ascribe to that domain is almost exclusively determined by that residue.
Okay.
So the form of your hair that you have is going to be determined by where that hair crosses. Because if it were all in direction that you were coming, it will collapse. It wouldn't be what you want. And I've never been able to demonstrate that, but I find very, very tantamount. I'm always kind of drawn to that. And it's a very powerful theorem that was discovered, let's just say discovered by this Swiss mathematician. I think it's Gauss. The famous Swiss mathematician. Not Euler, but the other one. I think it's Gauss. And it's very important. In nature, you always find that you have that big stuff and that little thing that comes into it disproportionately influences the behavior of the whole system.
All right.
Thank you. I think it's true.
Okay. I'll argue it later.
No,
Just
demonstration of
search
theorem
the theorem of
people.
residue. Yes.
Okay, well, let's see. I think we can finish this section. I think you read down to hierarchy here, didn't you, Joe?
I did. Thank you.
All right, good. So let's continue. Oops, sorry. Go ahead. Oh, there you go.
We saw how the octahedron emerges out of the arrangement of icosahedral edges on the inside, and now we reverse the situation. The icosahedron can be oriented so that 8 of its 20 faces are
Coplanar.
coplanar. Thank you.
Coplanar.
Or was it coplanar?
Coplanar, yeah.
Oh, coplanar. Forgive me. Thank you. Oh, man. With a flush against the 8 faces of a surrounding octahedron, while the 12 icosahedral vertices are located on its 12 edges. However, the icosahedron must sit in a skew or twisted position with its vertices intersecting the octahedral edges off center, dividing each edge into 2 segments. The longer 1.61a times the length of the shorter. The asymmetry means that there are two distinct orientations of the icosahedron inside the octahedron, positive and negative, as shown in 11-4A and 11-4B.
Isn't 1.68 phi?
Yes, of
Isn't
course.
that amazing? Of course.
Yes.
Yeah, there's phi.
Oh,
Okay, just thought I would
great call.
pretend like I knew something. Go ahead.
You do. The
Good,
ratio 1.68.
good observation.
Yeah.
Yeah. The ratio 1.18
Oh, there it goes.
to 1, known as the golden section, might have played a prominent role in synergetics, for it shows up frequently, especially in relation to the icosahedron. However, Fuller rarely he mentions the intriguing number. Accordingly, this text will not spend time exploring the famous ratio, which, as a source of fascination to geometers for millennia, enjoys considerable press already, specifically for the role played by the golden section in the icosahedron. See Loeb's contribution to synergetics and its addendum in Synergetics 2, both section G. Fuller has a different method of coping with such relationships, rather than describing certain comparisons and their numerical values. He employs geometric modules, a holistic way of describing geometry with geometry.
Okay, let's just pause right there for a second.
Sure.
Yes,
Any comments?
I'm going to make. I call on you again. Please go take the icosahedron, that is a structure, into a sphere, and the sphere being the IVM, and look at what surround the icosahedron. You will find the ratio. I did the calculation the other day. I shared with you that I interpolated it between, I had 0.59 and 0.69. You can calculate that. And to me, it says what surrounds the icosahedron within a sphere is a dampening phi. That's actually the way it was introduced to us, the dampening phi. And that dampening phi is the boundary. And we saw that the boundary is imposed out of structure. We are in structure. And we can, in our mimics, we can be in and out of our structures. But that boundary of a scenario universe that is finite is the phi. And do that in relationship to that pi that defines the sphere is a transcendental number, meaning that is not a rational number. It is among the irrational numbers, one that is not like a phi, because the phi, as we saw it, can be the convergence of a series of rational numbers. But pi, just like e, that is Neperian base of natural logarithm, is transcendental. It's something that we have to invoke outside of what we know. It is what it is. It is God stuff. That has to come and make rational our system of thought. That was my invitation to some So let's say when you have good time, when you are in good mood, just ponder at that.
Well, let's carry on with the what Emmy is saying is that Fuller, for some reason, kind of bypassed the importance of phi. Not that he was rejecting it, but he has another way, and maybe we can learn more about the other way, and we can come back to the emphasis on phi as you've been talking about, to try and understand what is it that Fuller was doing that had him kind of veer away from paying a lot of attention to phi.
Yeah, in fact, we're doing our phi study on Wednesday with cosmometry. Lafert's into phi up to his eyeballs. And this is showing, as Richard said, Fuller seemed to avoid the whole, he depended on these shapes. And he wanted to see this holistic geometry.
Okay,
So
I think there are two reasons, Steve, why Fuller avoided it. The one was that everybody was attacking him. People were, if you read the side story, that people were claiming that Fuller is not a scientist. That is just some guy. He doesn't understand even the mathematics that he's using. People were attacking Fuller that way.
yeah.
And the second thing is that phi has been appropriated by mysticists.
Yes.
It had been appropriated by people who have
Yes.
who read cards and all these things. I think it chose not to spend time on it and
Yeah.
just get to what he wanted as a result.
Yeah. If he got into phi, he got into sacred geometry and all that mystical stuff. And he wanted to be more scientific and be more practical. And so he was focusing
Yeah.
on the shapes rather than on that formula. Cool. Does somebody want to read from S modules?
We can read. We still have time.
Can we hold on? Can we hold on a second on the?
Okay, please,
the
let's hold
reason?
on.
Yeah, just bear with me 1 second.
Sure.
Thank you. I put on the chat so you got the names and you can look them up. Fuller worked very closely with Coxeter. Coxeter was a mathematician, geometer actually, and he was worked also. Coxeter worked very closely with Escher, an artist.
Yeah.
Escher is making all those geometries. Okay, and I don't have direct information, but my intuition on that is that he avoided phi also because his two colleagues were using it and abusing it. And so he decided to do away with it and say, okay, if you want to know about phi, there's other sources for you to know about phi. I'm not going to focus on that.
Yeah.
That's what I wanted to say.
Very
Thank
good.
you for waiting.
Very good. I think we still have a few minutes here. And yeah, we can get through this next section if we just possibly can. Who wants to read from S modules?
I can go ahead and finish it.
Okay, go for it, Joe.
S modules, the icosahedron's crooked position within an inscribing octahedron defines specific leftover space, 6 pockets of empty territory between the icosahedron and its octahedral embrace, 11-5. The symmetry of the 6 identical pockets is such that each can be split in half, producing two equivalent irregular tetrahedra, which then further divide into 2 mirror images halves. The final thin tetrahedron is Fuller's S quanta module. It is a volumetric unit that describes the degree to which the icosahedron is out of phase with the IVM, just as a grade school long division introduces the arithmetic remainder. The process of dividing an octahedron by an icosahedron requires a geometric remainder, the S module. Chapter 13 will describe Fuller's A modules and B modules, volumetric counterparts of the S module. Taken all together, these quantum units.
Good. Thank you.
No worries.
Sorry. There we go.
Comprise Fuller's finite accounting system. Finally, 11-5 indicates the golden section ratio between different edge lengths of the S module.
Yeah.
Okay, let's read. We just have a little bit more to read unless there are
Sure.
comments.
Icosahedron and Rhombic Dodecahedron, a pattern emerges. The out-of-phase relationship between the icosahedron and different IVM polyhedra appears to involve the golden section. We test the pattern on the rhombic dodecahedron. Do its 12 faces correspond with the 12 vertices of the icosahedron? It turns out that the two shapes exhibit an interesting relationship, with the icosahedron fitting inside the rhombic dodecahedron, predictably in a skew position. Its vertices impinge on the rhombic faces slightly off center, dividing the long diagonal of each diamond into two unequal segments, the longer again 1.618 times the length of the shorter, figure 11-6. Every reliable, the golden section reinforces our awareness of the underlying order in space.
There's that diagram showing the 1.618 right yonder.
Oh, yes.
Here's 1.618.
Yes. I mean, and then if you look at the upper section is 1, and the lower one is 0.618.
The way this has the upper section is 1.618 and the lower section is 1. Is that what you said?
No, that's not what I said. I took it in the representation that we had in the sphere.
Oh, okay.
Where you took the closely packed.
Yeah.
Yes, at the second frequency, and then you have the one that was horizontal, and then to the sphere that surrounded it was the golden ratio, was 0.6.
Here they appear again. And you can finish this paragraph, and I don't want to push this too far, but see what you can do about finishing. We have two more paragraphs if we can finish them off tonight.
Or the golden ratio relationship like Icosa, rhombic dodecahedron, the golden section.
Wait a minute. Did we read this? I think we missed this. I screwed up. There we go.
The icosahedron and rhombic dodecahedron, a pattern emerges. The out-of-phase relationships between the icosahedron and different IVM polyhedra appears to involve the golden section. We test the pattern on the rhombic dodecahedron due to its 12. We read this.
We read that?
Yeah.
We read that.
You finish
Yes.
that? Okay, we're on to the next page. There we go.
Oh, like I thought I was going nuts there for a moment. Pentagonal dodecahedron. Finally, recall the pentagonal faces of the icosahedron dual. The fivefold symmetry of the dodecahedron is right out in the open. Furthermore, the pentagon is a prime source of golden section ratios. See Loeb's contribution to synergetics. The pentagonal dodecahedron is, of course, also out of phase with the IVM. For its symmetry scheme is the same as that of its dual.
Of the icosahedron.
Yeah.
Yes.
Very cool. We're going to stop our reading there for tonight. Any other comments? We'll just.
To me, the whole of this is the application of the principle of duality.
Mm-hmm.
Nothing exists on its own. There is always a companion for that dance. The second thing is that when you take the particular icosahedron, we saw that it was discrete. It was just, on its own, without all of the reinforcement vertices from a center. It's just a shell. That icosahedron, if you now take the rhombic dodecahedron, has 12 vertices instead of 12 faces. It has 12 vertices and 20 edges. Now imagine it, and each of its vertex come at the center of gravity of a regular triangle of the icosahedron. So it is a star bursting out of icosahedron to complement it. And as we saw on this figure of the tetrahedron and the star, the two tetrahedra, that comes at 90 degrees of each other. One is the stable one, the gravitational one, the compressive one, and the other one is the explosive one. The white here is explosive. That is exactly the same, because if you take this white tetrahedra, its vertex comes at the center of gravity of this phase of the, I will call yellow tetrahedron. The two embrace in a yin and yang, like that.
So true.
So one is always gravitational, the other one is radiational, is explosive. And that's what happened between the icosahedron and the rhombic dodecahedron.
Cool.
And if you put the icosahedron and the rhombic dodecahedron together, you can envelope it with the cube octahedron. That is the closest mimic of our sphere that we imagine. I think that's what she's done here. She's done in figure 1116, where the golden ratio exists. That's what she did.
11.6.
Yes,
Yeah.
11.6.
And here's what came to me, because I said incorrectly that I asked if they were duals. They're not duals,
No.
because it says here they're offset slightly. The offset is the ratio. The offset is the 1.618 to the 1. If it were duals, that edge would be divided in half, but it's not divided in half. It's divided by the golden section. It's 1 to 1.6 instead of 1 to 1.
Yeah.
That was an epiphany for me, because she kept saying it's offset. I'm going, what's the offset? All of a sudden we see phi show up here. So I get the offset now. That was big time for me. Any other thoughts?
It's
or
actually,
questions on
it
this?
was already offset from the icosahedron already.
Right.
You see, the icosahedron, when it collapses into the icosahedron,
Right.
that was on its own, it was offset. It didn't follow the symmetry that you will have with the octahedron and the tetrahedron. It does not
Right.
follow that.
Very cool.
So
Any other comments?
so if it is offset, his dual is also going to be offset, because they are 90 degrees.
Yeah.
Yes.
Cool. Any other comments on this before we shut it down and go into our takeaways? Going once? Okay, twice, gone. Wow, Richard, how are you feeling? And what are your takeaways?
Well, I'm feeling intrigued with it all. I'm somewhat lost in making sure I had all the numbers right. I just captured the sense of the rectangular shape is 1 on one side and 1.16 on the other side. So that's the measurements of the rectangular part of the rhombic.
So I'm taking that away. I guess I'm still still intrigued with the motions that one sees as you move through the jitterbug down into the icosahedron to the octahedron to the tetrahedron, and seeing all of the elements of motion, from the precession motion, the spin, the orbit, the torque, the in and out, and the expansion contraction. And I've always been intrigued more recently with how those six motions apply in a human relationship context. And that's how I've been trying to understand them in a model that I've been working on. And so that's kind of where I'm still. My mind is thinking about the motions that one experiences with the icosahedron, or with the the jitterbug, yes, moving down through all of the different sort of shapes and sizes to the minimum triangle and back up again in a self-organizing kind of way without ever sort of breaking the actual pattern. So that's still my biggest takeaway, and I still need to go back through the details of the readings that we just went through today. So that keeps me on the learning curve. So that's my big takeaway. And Manu, how are you feeling? What's your takeaway?
I'm feeling excited. We felt Fred again, already. So it's going to evolve here, very, very quickly. Now, I'm always kind of astonished how simple things can contribute so fundamentally in the diversity and the beauty of expression of nature. And those two things are simple. Is the triangle and the rhombus. Associated give everything that we have in nature. It is again the promiscuity, the true everywhere of the law of duality. What I'm saying, the triangle and the rhombus, is that the triangle is rigid. The rhombus is flexible. Rigidity plus flexibility gives me every twist that I want. And in having that twist, I need to hold somewhere in a polar position for the twist to make sense to me. Otherwise, it's just going to be some jungle dance. It needs to be conducted. And that, to me, is a music, universal music. Rigid, the flexible, together dance according to a certain direction given. That is my topological triangle. That is the fundamental at the beginning. And with this, I'm very grateful that this session took me to some place where I think I've grown. And I'm very appreciative of the contribution of everybody. Lee, how do you feel? What do you take away?
There you go.
It's almost impossible to get my phone to work. It's a triangular entity in my life that I have to still understand. But thank you, Manu, for helping me to understand a little bit more about Jitterbug and having the triangle so firm, and then that is rigid, and then having the tetrahedron where we can jitterbug it to collapse to be completely flat and then raise it back up. You have given me a lot of information that I was so confused about throughout the whole evening, mathematically, since mathematical problems are a major problem for me. I am still learning an awful lot, but I am very grateful for having seen how that jitterbug can be so flexible with the triangle within it. Is that so?
Don't doubt yourself.
I'm in awe of it all. Thank you for that, Manu, and I'm very grateful for it. Now, Fred, I believe you have an opportunity to give us your viewpoint on tonight's views, and what have you found?
Thank you, Lee. That was a lot to take. That was a lot. More than half a page of Bucky is already a lot. Today we did what, 5 pages? You guys are nuts.
Yeah.
That's all right. My takeaway is that you can do mathematics without doing mathematics, and it's fairly apprehendable. And I'll give an example with universe and set theory. And if you can wrap your head around that, you're an expert in set theory. And that's from another card from Bucky's dictionary, is the universe. To each of us, universe must be all that isn't me plus me.
Mhm.
If you can wrap your head around that, you're an expert in set theory, and you can do mathematics at a very, very high level. So that's my takeaway today. Universe is everything that is not me plus me. And that is true for each one of us. So next is Joe, is that correct?
Yeah.
Yeah.
Joe? Okay. Joe, what's your takeaway? What's your takeaway today? And thank you very much, everyone.
Well, first, welcome, Fred, and I appreciate your contributions here this evening. It's been fantastic, and I really appreciate your opening and your where you shared a little bit about yourself and some of your personal experiences. That means a lot. It's Richard, I'm actually glad your daughter's doing well. That's that's a relief, obviously. Manu, thanks for getting up at 5 a.m. And Stephen and Lee, it's always great to see you. Without a doubt, there's a lot to take away. There was a lot we covered. The quotes that were put up. But something that actually Fred put up that really kind of, is kind of aligning with what Manu had talked about a lot this evening and what Amy had been writing about and made it a little bit more clear, was that all boundaries are porous. That there's no strict divisions. And, and I put together a little thing, and I'll put it in chat, is that, that's pretty much my takeaway. Because it actually relates directly to consciousness and some things that I've been looking at in terms of recursion. So that, that there's no strict division, there's no inside and outside the self and other subject and object. There's always some exchange. And so that when we look at it in terms of recursive superintelligence, that's what RSI stands for. It's the idea of the watcher, the self-editor, and then the subject and the object unity, and how that relates to the consciousness. And so that one statement that you put in the chat, Fred, was exactly recursive superintelligence. So it's basically the idea that if an AI can never become self-aware, and so that the system is calling on itself. So it's it's a form of recursion. So where the subject and the object understand that they're the same. So so that's yeah, that I mean, but you putting that one statement in, about the boundaries, essentially, that was really, really helpful for me. And because it really aligned with everything that we read in the text, and especially the idea that how the geometric objects relate to one another. So that was really cool. So that's definitely my takeaway. And it kind of continues to give insight as to the depth of which Fuller was actually giving us with, when we're thinking geometrically, he was always talking about consciousness. And so, and really, what does it mean to be self-aware and to live in the world? So, Steve, how you feeling? What are you taking away from today?
Thanks, Joe. Hey, I'm excited to I was excited to be on this call. Fred, it's good to have you back. And I'm delighted that you learned how to push the share button. Feel free to do it anytime you want to. Very democratic here. A little bit different than Kelly used to run it. I think Kelly had an agenda and he moved along. My agenda is to see as much of this as possible and allow everybody to share as much as they can see about it. Sometimes I'm a little stuck. I'll tell you, I had a vision tonight as I've been between cosmometry, which goes into phi in a major freaking way, and really goes into fractalization, or just how fractals work in the universe. It was really cool when Manu held up the two-dimensional icosahedron, the two-dimensional universe, flattened it all out. It was mind-boggling to me. And the hypergraphness of it all. This idea in the isotropic vector matrix that all of the radii have this potential of being equal. And many times in some of these polyhedra manifest absolutely equally. And then they get into the cube octahedron, and all of a sudden we shift from triangles to squares. And so there's this interrelationship. And what I saw tonight was that the jitterbug that Bucky uses is a great metaphor. But what I understand reading tonight, it's not just crashing through. In fact, I have a picture of the breakout of the jitterbug. These are the shapes that, whoops, wrong. I went too far there, pardon me. I hit a button. There it is. Okay. So here are the shapes of the jitterbug as the jitterbug goes through. But this is actually just a metaphor because as the book is explaining, the icosahedron, the rhombic dodecahedron, these things are manifesting within this exchange of energy as this jitterbug moves. And in this, the vision I'm seeing, and I'm opening up, I mean, just trying the words, here's this isotropic vector matrix with all these radii that are potentially equal, and yet here are all these shapes. The cube octahedron or the vector equilibrium can manifest anywhere in this isotropic vector matrix. And then as it starts to destabilize and go through these different forms, these are a bunch of local events that sometimes overlap. And I'm getting some of this wording about universe and human experience and these polyhedral shapes, how they're interreacting, and the fact that they're offset, or rather than dissecting equally, multiply to divide with duals, they're offset by this phi, which Bucky wants to call S modules, which is fine with me. And I'll learn more about that. But anyway, suddenly I'm seeing the jitterbug as a metaphor of something else that's really quite mind-boggling, between the octahedron, the icosahedron, the rhombic dodecahedron, that life is happening. And that's, my brain is barely grappling around it. What I would love to do, if I had nothing on my plate right now, I would learn graphics, and I would do this book with 3D modeling. That's what I would do. So that you could take these things and then say, okay, here's the icosahedron. We're going to offset it by 1.618, 1 to 1.618. We're going to twist it and then see all these duals appear, and how seeing 3D graphics on this book would be mind-boggling, because that's what my brain is trying to create the whole time. I'm very visual. So anyway, I had a great time tonight. I loved everybody's feedback. Wish the best for your daughter, Richard. Wish the best for your mom, Joe. And I'm just excited that we're all here. And we missed Ann today, but she'll be here soon. And then we'll connect when we connect again. I'm complete. Is there any last minute sharing before we? I see a new share down here.
No, it was just a real quick reply. So
Yeah. And thanks, Joe, for bringing up that RSI stuff. I think that this whole concept, the large language models, I shared last time, I think on Wednesday, about how they're using AI. They set up a 20-mile boundary in the Caribbean, and they're tracking whales and which whales are talking, and AI is keeping track of all that and noticing who's talking and who's answering and when they're answering and what they're answering to and whether they're eating while they're doing it or not. And somehow we're kind of understanding more how whales communicate. And I think our words are just so limited. We think we're so cool, but wouldn't it be cool if we could sing this stuff? And I think Bucky was trying to sing this stuff, but he was limited to words. There you go. Any other comments or questions before we go? Okay.
There's a marathon. There's a marathon, the Bloberg Marathon running. I'm going to look at it from my window.
Cool.
It's this morning. They started earlier.
Okay.
It's going to be beautiful.
All right.
Okay, Doc.
Bye-bye.
Bye.
Thank you. Bye-bye.